Now, before we go into this topic, there's a quick concept of angular velocity that I need to go over with you. So let's say we have this satellite orbiting Earth. When we usually talk about velocity and speed, we refer to the linear velocity of an object. And in this case, the linear velocity of this object is straight across, tangential to its circular path. The satellite is going in a circular orbit around the Earth. The linear velocity is tangential. So if this satellite was here, the linear velocity would be that way. And this is something that you already familiar with. Now, angular velocity for particularly things in circular motion is given by how quickly this angle changes with time. And angular velocity is denoted by this Greek letter omega. And it looks like a W, but it's not quite. The definition for angular velocity is the rate of change in radians. And that's basically the rate of change in angle. But the angle that we are particularly going to be using, or the unit of angles that we're going to be using, is radians. And the formula for the angular velocity is omega is equal to 2 pi over t, where t is the time period for one full oscillation. Or in this case, it would be one full circle. And the reason for this 2 pi is that it's because it is the angle in a circle. When you go round a circle once, you travel 2 pi radians. So the unit for omega is radians per second. So how is linear speed related to angular velocity? Well, the time taken for an object traveling at the speed of v to go around in a circle is going to be equal to the speed, which is v, times the distance traveled. And the distance traveled when it travels in one loop is simply going to be the circumference of a circle. So that's going to be 2 pi r. So your time period is equal to 2 pi r over v. Now, from the previous angular velocity equation, we saw that omega is equal to 2 pi over t. So if you rearrange this, you get t is equal to 2 pi over omega. And if you substitute that in for t here, you get 2 pi over omega equals 2 pi r over v. And if you rearrange this equation, you're going to get that v is equal to omega r, where r is the radius of this circle. So this here is a relationship between linear velocity and angular velocity. Now we know that if this object was traveling at an angular velocity of omega, now if it travels that angle in a time of t seconds, well, we know that therefore the angle is equal to 2 pi times little t over big T, which is the time taken to traverse the angle theta over the time taken for one full period. And we know that 2 pi over t is equal to omega, so we can write theta as equal to omega t. And this equation can be used for objects that have a constant angular velocity. Now, the best piece of advice I can give you after watching that video is to go off and practice some past papers or topic questions. These are single-handedly the best way to help you commit the content you've learned to memory. Obviously, go and do all the YouTube stuff of liking, subscribing, and if you found this video helpful, feel free to go and watch any of my other ones.